Comes from what you can't see, and it's happening way out there.
The great Southern Ocean, vast and unspoiled, or so we'd thought.
Projections are in about by the middle of this century that we'll cross the threshold in the Southern Ocean where that hasn't been seen for many millions of years based on geological evidence. And when that happens, organisms that grow, for example, shells, calcium carbonate shells, and some of them are important in the ecosystem there, will really struggle to grow.
From the depths here, evidence of how the ocean's natural ability to absorb carbon dioxide is being overwhelmed. The world's oceans are becoming more acidic, and it's happening more quickly in the cold waters of the Southern Ocean between Australia and Antarctica.
The CO2 that's causing this acidification is going up in the atmosphere at much faster rates than you would expect from natural processes, and it's causing rapid change, and the oceans have different mechanisms to account for that, but they occur over thousands and thousands of years, so we're just pushing carbon into the ocean too rapidly now for the system to adjust itself and offset this problem.
Oysters, clams, there's a whole range of organisms which depend on this shell-making ability, and they're all living in or near the surface waters of the ocean. That's where the biggest impact is being felt.
Okay. So this is where you keep them?
This is where we keep all the samples that we've been collecting over a 10-year time period, split into little jars like this. They're kept preserved and buffered so that they can be, so that their chemistry and especially the shell structure is not altered.
An early warning has come from the tiniest of organisms, seashells the size of a grain of sand. Their ability to make shells is being crippled by the growing acidity of the water.
These organisms are the base of the marine food webs, and what happens to them ultimately reverberates throughout the ecosystem, right up to whales, penguins, and a lot of the kind of organisms that we're used to seeing, used to enjoying, and many of them used to exploiting. So what happens at that part of the marine ecosystem ultimately will affect us one way or another.
Further evidence has come from a Sydney PhD student. Laura Parker was suddenly thrust into the scientific limelight when she discovered abnormalities in the shells of young oysters.
So what are you going to look for now in these?
Well, these oysters have also been exposed to ocean acidification, so what we'll go and do now is look at them under the microscope and just have a look whether they've had any reduced growth because of the ocean acidification. It's quite scary because oysters tend to be bioindicators, so anything that happens to oysters generally may happen to other organisms in the environment. So it's very scary to see that oysters are affected so badly because it means that we may see the other organisms in our marine ecosystems also being affected.
And more alarming evidence, this time from a recently discovered reef near the Antarctic shelf, deep beneath the Southern Ocean.
We have this complete community sitting down there that straddles the current saturation horizon. And as that saturation horizon goes up and down, the community will respond to it over time. And if we can look at, and we're looking at the response of the community as this thing is changing, and it'll allow us to forecast the ultimate fate of these things. I mean, what happens if the saturation horizon really gets up to 500 meters, which is what they're forecasting. I mean, we expect most of these corals won't be able to tolerate that, but we need to find out for sure and come up with some sort of adaptation strategy.
The saturation horizon being this point of so much acid.
Yes, that the corals can't grow anymore, or basically can't survive. Their skeletons begin to dissolve, and that's we think is the tipping point. You know, as long as there's plenty of carbonate in the water, these things can grow. But as you get deeper and deeper, it gets more and more acidic. There's less and less carbonate in the water, and suddenly the things are struggling to get enough carbon ions to pull in to grow their skeletons, and that's the critical bit.
The changing chemistry of these waters is now seen as the biggest threat to our oceans. Ocean scientists once thought so resilient. Ian Williams, NBC News, Tasmania.